Hey there. Ready for a deep dive into some seriously cool tech?
I am.
Great. Today we're going to be looking at Microsoft's Majorana 1 quantum chip.
Oh, cool.
Yeah, you know how some problems are so complex that even our best computers would take like forever to solve?
Yeah.
Quantum computing could change all that.
Could it really?
Microsoft thinks they've made a pretty huge leap forward with this one.
Oh, wow. That's exciting.
It is exciting. So, what makes this Majorana 1 so special?
Oh, I'm very curious to find out.
Microsoft says it's not just another quantum chip. They're using a topological core, which is built with this material called a topoconductor.
A topo what?
A topoconductor.
Okay, topoconductor. Interesting.
Have you ever heard of that?
Not really, no.
Yeah, I hadn't either until I read this research. So
Okay. So, I mean, it sounds pretty cool, though.
it does. So tell us a little bit about what a topoconductor is.
Well, topoconductors are really fascinating because they tap into, like, the strangeness of quantum mechanics to create these incredibly stable qubits. Think of qubits as the building blocks of quantum computers.
Yeah.
One of the biggest hurdles in the field has been that qubits are, like, super sensitive and prone to errors.
Right.
But these topological qubits,
Yeah.
much more robust, much more reliable.
That's a really big deal, right?
Oh, huge.
It's like they've built error correction right into the hardware.
Exactly.
And get this, their goal is to fit 1 million of these super stable qubits onto a chip the size of your hand.
Wow, 1 million.
1 million.
That's incredible.
It's a lot of qubits.
To really unlock the potential of quantum computing and tackle those massive problems, I mean, you really need that scale.
Right.
It's about harnessing the power of a whole data center in something you could hold in your palm.
It's like mind-boggling to think about.
I know.
It is. It is. So, okay, with that kind of power, what kind of problems are we talking about solving?
One area that I'm particularly interested in is the potential to break down microplastics.
Yeah, that was something that really jumped out at me when I was reading about this as well.
We all know how big of a problem plastic pollution is.
Right.
Imagine a quantum computer helping us find ways to break down those microplastics into harmless substances.
Wow, that would be incredible.
Right?
What other potential applications are there?
They've also mentioned the possibility of designing self-healing materials.
Oh, really?
Think of a phone screen that repairs itself.
Oh, okay.
Yeah.
So no more cracked screens.
Maybe not.
Oh, man, I'm sold. But seriously, think about how that could revolutionize so many industries.
Absolutely.
Imagine engineers designing the perfect product on the first try. No more trial and error.
That would be like a dream.
It would.
And, on a larger scale, quantum computers could help us model incredibly complex systems, like those involved in climate change, potentially leading to solutions we can't even imagine yet.
It's clear that Microsoft is going all in on this technology.
It seems like it, yeah.
They've even called their topological qubit the transistor of the quantum age. That's a pretty bold claim, right?
It is, and it speaks to their focus on building a foundation for, like, a whole new era of computing, prioritizing reliability and scalability from the ground up.
Yeah.
Just like the transistor revolutionized electronics, they believe their qubit could do the same for quantum computing.
Okay, so how do they actually create these game-changing qubits?
Yeah, I'm curious about that too.
It all comes down to these mysterious things called Majorana particles, right?
Yes. This is where it gets particularly interesting.
Okay.
These particles exist in a strange quantum state where they act as their own antiparticles.
Okay, hold on.
It's a concept that's pretty mind-bending,
Yeah.
even for those of us who work in the field.
I was going to say, I'm having a little bit of trouble wrapping my head around that one.
Yeah.
Can you explain, like, what it means for a particle to be its own antiparticle? It
Right.
sounds like something out of science fiction.
It does sound strange, doesn't it? In the quantum world, things can exist in multiple states at once.
Mm-hmm.
Imagine a coin spinning in the air. It's both heads and tails at the same time until it lands, right?
Yeah.
That's similar to what's called superposition in quantum mechanics.
Okay.
And a major and a particle exists in a superposition of both a particle and its antiparticle simultaneously.
So it's like it's two opposite things at the same time.
Exactly.
That's pretty wild.
It is. It's really quite fascinating.
But how does that make it useful for quantum computing?
Well, that dual nature,
Yeah.
it's exactly what makes Majorana particles so stable.
Okay.
Remember how we talked about regular qubits being, like, fragile and prone to errors?
Right.
This unique property of Majorana particles makes them much more resilient.
So they're kind of like the superheroes of the quantum world.
You could say that.
They've harnessed these superhero particles.
Yeah,
That's impressive, but like, how do you even find a Majorana particle?
that's the catch.
Okay.
You can't just find them lying around. They have to be created under very specific conditions.
Okay.
It's like coaxing them into existence using superconductors and magnetic fields. It requires incredibly precise engineering at the atomic level.
Wow, that sounds incredibly complex.
It is, but it's also incredibly exciting.
And I bet it's not easy to do.
You're right, it's cutting-edge science and engineering.
Yeah.
Microsoft has been working on this for years,
Wow.
and they're not the only ones, you know.
Oh.
It's a global race to build practical quantum computers
Yeah.
with a lot of brilliant minds pushing the boundaries of what's possible.
It's incredible to think about how much effort is going into this all over the world.
I know, it's really quite remarkable.
But the potential payoff seems to be worth it.
It does.
Microsoft's involvement in this DARPA program, that's focused on developing a commercially viable quantum computer,
Right.
that's a pretty big deal.
It is.
DARPA is known for funding, high-risk, high-reward projects.
Right.
So their involvement definitely adds credibility to Microsoft's claims, and it just really highlights the potential impact of this whole technology.
Yeah, absolutely.
Now that we've covered the basics of what Microsoft is doing with this, let's dive deeper into the science behind these Majorana particles and how they actually create these qubits.
All right. Sounds good.
But first, we'll take a quick break.
Okay. All right, so let's get back to those, mind-bending Majorana particles.
Okay.
Remember how we talked about them being in a state of superposition?
Yes.
Like a spinning coin being both heads and tails at the same time?
Right.
Well, a Majorana particle is in a similar state,
Okay.
existing as both a particle and its antiparticle.
Wait, so it's not that it could be either one, it's both at the same time?
Exactly.
It's like it can't decide what it wants to be.
You could say that.
And this indecisiveness, so to speak, is what makes them so stable.
That's a big part of it, yeah.
Okay, so normal particles and antiparticles, they annihilate each other when they meet, right? But a Majorana particle, being its own antiparticle, it doesn't have that problem.
No.
So it's inherently balanced and less prone to, those disruptions that cause errors in regular qubits.
Exactly.
Okay, I think I'm starting to get it.
Good.
So the stability is what makes them so promising for building, more reliable qubits.
Yeah.
But how do they actually build a qubit using these particles? Do they just, find them somewhere and plug them in?
Haha, no, not quite.
Okay.
It's a super intricate process.
Okay.
It involves manipulating materials at the atomic level.
Wow.
They start with a special semiconductor material,
Okay.
indium arsenide,
Okay.
and they cool it down to extremely low temperatures,
How low are we talking?
much colder than anything you'd find naturally in the universe.
Yeah, that sounds chilly.
It is. At these ultra-low temperatures, the indium arsenide behaves like a superconductor, which is key to creating the right environment for those Majorana particles to emerge.
Oh, okay. So they need those super cold temperatures to, coax them into existence.
Right.
And then they apply carefully calibrated magnetic fields to the superconductor.
Exactly.
And that's what actually creates them.
Yes, it's a really remarkable process.
So they're not just finding these particles, they're actually creating them. That's next level science.
It really is. It requires a deep understanding of both quantum mechanics and materials science.
And even then, it's still a delicate process.
Very much so. There are many potential pitfalls.
But the payoff is huge.
Oh, yeah.
Qubits that are far more resilient than anything we've been able to create before.
That's the goal.
So they've created these stable Majorana-based qubits, but how do they even know it worked? I mean, these particles are tiny. How do they even measure them?
Yeah, that was another hurdle they had to overcome.
I bet.
They had to develop an entirely new way to measure these qubits because the way they store information is kind of hidden.
Hidden?
Yeah, think of it like trying to read a book without opening it.
Okay.
They found a way to use microwaves to gently probe the qubit state without disrupting those delicate quantum properties.
So it's like they figured out how to listen to the qubits' whispers.
That's a good way to put it.
But even with all these breakthroughs, there must be challenges to making this work on a larger scale, right?
Oh, absolutely.
I mean, 1,000,000 qubits is a lot of qubits.
It is a lot, and while Microsoft's approach is groundbreaking, it's still early days.
Right.
One of the biggest challenges would be scaling up the manufacturing process.
Oh, okay.
Right now, they're creating these qubits one at a time.
Yeah.
It's a very meticulous process.
I can imagine.
To make millions of them, they'll need to find a way to automate and streamline the production.
Okay, so it sounds like a pretty tall order.
It is.
It's not like they can just 3D print these things, right?
Not quite. It requires an incredible level of precision and control.
Right.
But the good news is they're not alone in this challenge.
Okay.
The entire field of quantum computing is working on similar problems.
Yeah.
And there's a lot of collaboration and knowledge sharing happening.
So it's like a giant scientific puzzle, and everyone's working together to, like, figure out the pieces.
Exactly.
And as we solve these engineering and scaling challenges, the real excitement begins.
It does.
What are we going to do with all this quantum computing power?
Exactly. It's an exciting time to be in this field.
I mean, we've talked about a few applications, but I really want to, like, explore those in more detail.
Sure.
Imagine, for instance, the impact on drug discovery.
Oh, yeah, that's a big one.
That one really stood out to me when I was reading about all of this.
For sure.
Can you explain how quantum computers could revolutionize the way we develop new medicines?
Well, imagine being able to simulate the interactions of molecules at the quantum level.
Okay.
That's something that's incredibly difficult, if not impossible, for classical computers to do.
Right.
But with a quantum computer, we could potentially design and test new drugs virtually.
Wow.
And that could drastically reduce the time and cost of bringing those life-saving treatments to market.
So instead of years of lab work and millions of dollars spent, we could potentially design new drugs in a fraction of the time, all thanks to quantum computing.
That's the hope.
That's incredible. What other areas could be transformed in a similar way?
Well, another area with massive potential is materials science.
Okay.
We talked about self-healing materials, but imagine designing new materials with tailored properties for everything from energy storage to superconductivity.
Okay, so what, like solar panels that
Yeah.
are vastly more efficient?
Exactly.
Or batteries that last for weeks on a single charge?
That's the idea.
It sounds like a whole new world of possibilities is opening up.
It really does.
And let's not forget about artificial intelligence.
Oh, yeah.
Quantum computers could lead to breakthroughs in machine learning and data analysis,
Absolutely.
potentially enabling us to solve problems in areas like climate modeling or financial forecasting,
Right.
problems that are currently beyond our grasp. So we've got potentially life-saving drugs, super efficient energy, and AI that can solve some of the world's biggest problems.
It's pretty amazing to think about.
This is starting to sound less like science fiction and more like a glimpse into the future.
I agree.
But with all this incredible potential, there must also be some concerns, right?
Of course.
I mean, this is powerful technology we're talking about.
You're right. The potential benefits are enormous, but so are the potential risks.
Like what?
As with any powerful technology, there's always the possibility of misuse.
Right.
For example, quantum computers could be used to break the encryption that protects our online data,
Oh, okay.
or to develop more powerful weapons.
So it's not all sunshine and roses then.
Not necessarily, no.
We need to be thinking about the ethical implications of this technology as well, right?
Absolutely.
It's crucial that we have these conversations now while the technology is still in its early stages.
I agree.
You know, we need to consider the potential societal impact, put safeguards in place to ensure that quantum computing is used responsibly and ethically.
That's a really important point.
It sounds like we're standing at a crossroads with a path toward amazing advancements, but also some potential pitfalls.
Yeah, I think that's a good way to put it.
What steps can we take as a society to make sure we're heading in the right direction?
That's a great question, and I think it starts with education and open dialogue.
Okay.
The more people understand about quantum computing and its potential impacts, the better equipped we'll be to make those informed decisions about its development and use.
It makes sense we need to be having these conversations not just in the scientific community, but in society as a whole, right?
Absolutely. It's not just about the scientists and engineers, it's about all of us.
We all have a stake in shaping the future of this technology.
We do.
This has been an incredibly eye-opening conversation.
It has.
I feel like I've just had a crash course in quantum computing and its potential to change the world.
Me too.
It really is.
It's a truly fascinating field, and it's moving at an incredible pace.
It is.
Who knows what breakthroughs we'll see in the next few years?
It's both exciting and a little daunting to think about.
It is, yeah.
But one thing's for sure, we're living in a time of incredible technological advancement.
That's for sure.
And quantum computing is right at the forefront of all that change.
It is.
As we wrap up this deep dive, I want to leave our listeners with a final thought. We've talked about the science, the potential applications, and even, some of the ethical concerns surrounding quantum computing.
Yeah.
But what I find like most fascinating is the sheer scale of the change it could bring.
Right. It's crazy.
It's not just about making things a little faster or a little better.
Right.
It's about solving problems that we previously considered unsolvable.
It really is a paradigm shift.
It is.
It's like we've been working with a basic calculator all this time.
Yeah.
And suddenly someone hands us a supercomputer.
Yeah.
The potential to transform industries, advance scientific understanding,
Yeah.
and even address global challenges is truly immense.
It's not even just about the specific applications either, right? It's about the ripple effects that those breakthroughs could create.
Exactly.
Like, for instance, if we can, like, model complex systems like climate change with much greater accuracy,
Yeah.
that could lead to entirely new approaches to, like, mitigating its effects.
Exactly. The solutions we find through quantum computing could cascade into other fields, leading to innovations we haven't even thought of yet.
Yeah.
It's like opening a door to a whole new world of possibilities.
It's almost a bit overwhelming to think about.
It is.
It makes you wonder, like, are we even prepared for the kind of rapid change that quantum computing could bring?
I think that's a really valid point.
Yeah.
The pace of technological advancement is already, like, accelerating so rapidly.
It is.
And quantum computing could be a major catalyst for even faster change.
Right.
And it's important that we as a society are prepared to adapt to those changes.
Yeah.
Embrace the opportunities while also addressing the potential challenges.
I think that brings us back to something that we touched on earlier,
Yeah.
like the importance of open dialogue in education.
For sure.
The more we all understand about this technology, the better equipped we'll be to, like, navigate its impact.
I couldn't agree more.
Yeah. Yeah.
We need to demystify quantum computing, make it accessible to people outside of the scientific community.
Right.
It shouldn't be seen as some, like, esoteric, futuristic concept.
Yeah.
It's something that has the potential to affect all of our lives.
It does.
And therefore, we all have a role to play in shaping its trajectory.
It sounds like a call to action.
It is.
We need to engage with this technology, learn about it, discuss it, think critically about its implications.
Exactly. And that engagement needs to happen at all levels, from, government policies and industry regulations to individual choices about how we use and interact with quantum-powered technologies.
Right. So, to our listeners, we leave you with this challenge. Don't just be a spectator in this quantum revolution.
Right.
Be an active participant.
Right.
Learn about the technology, ask questions,
Yeah.
and share your thoughts.
For sure.
The future of quantum computing isn't predetermined.
No.
Something we're all shaping together.
And as we step into this new era, let's do so with a sense of responsibility, curiosity, and a commitment to using this powerful technology for the, betterment of humanity.
That's a perfect note to end on.
It is.
Thanks for joining us on this deep dive into the world of quantum computing.
It's been fun.
It has.
Thanks for having me.
We hope you found it as fascinating and thought-provoking as we did.
I hope so.
Until next time, keep exploring, keep questioning, and keep diving deep.